Okay, looking at transformation of graphs today. Okay, not bad. Not many to do. Okay. Describe the transformations necessary to transform the graph of f of x, the solid line, into that of the dashed line. So, I mean, this is a quadratic, and in fact, it's actually f of x equals x squared. And I should be able to recognize simple functions and their graphs like this. But anyway, to get to the point, first you need to flip it upside down. So you need to make it negative x squared. And then you need to translate it to the left by 3 units. Now the way to do that is to go in where the x is, bracket it, and add 3 to it. That will translate it to the left by 3 units. This is the absolute value function. And the right ray here has become sort of half as steep. So that's fine. And then it needs to be translated upwards by 3 units. So f of x is the absolute of half of x plus 3. And we check. Right, okay, so what they mean is not, they mean quite literally describe. All right, so I would say reflected across the x-axis, translated by -3 or translated 3 units left. I'll just say left. Yeah, that's fine. And here, I suppose you could say stretched horizontally by a factor of 2. Translated 3 units up. Okay, so what they say is compressed vertically. Fine. We could do it that way as well. That's equivalent in this particular case. Describe the transformations necessary to transform the graph of f of x into that of g of x. Well, reflected across x-axis, stretched vertically by factor of 3. Translated down by 1. Here, stretched vertically by a factor of 3, translated 1 unit left. And we check. Okay, so they say expanded vertically, but that's fine. But we want to know what the most common verbiage is for this. Okay, so I have a function f of x. I apply the following transformation to it. We'll say 3 times f of x. No. F of 2x plus 5 plus 7. Four changes in 4 bullet points in the most common phrasing. Okay. Horizontal compression by a factor of 2. Horizontal compression by a factor of 2. Horizontal shift left. Okay, that's very, very, very important. A horizontal shift left by 502 units. I think that I may have nearly neglected that. Anyway, here we go. Transform the given function f of x as described and write the resulting function as an equation. F of x equals x squared, expand vertically by a factor of 3 and translate down by 3 units. All right. Want to expand it vertically by a factor of 3. And I want to translate it down by 3 units there. Compress horizontally by a factor of 2. Compress horizontally by a factor of 2. And translate to the left by 3 units. So here I know ahead of time that the asymptote is 0. The asymptote is x equals 0. So if I were to put, if I were to do this, would that be okay? Yeah, that would be okay, because that moves it left by I mean, the thing is, it's good. Well, +3, of course. But I stick in -3 now, and it breaks, and that's exactly what I want. All right, okay, so we check. And that's correct. Expand horizontally by a factor of 2. To expand this horizontally by a factor of 2, do that. Then translate it right by 1 unit and up by 3 units. Right by 1 unit, up by 3 units, there. Compress vertically by a factor of 3. And reflect it across the x-axis. Okay, so that'll be -1/3 of root x for the first 2 transformations. And now translate it right by 2 units and down by 3 units. So we go in where the function is, where the x is, and we want to translate it right by 2 units. So we do x -2 and translate it down by 3 units. So we do -3 there. And we check. And that's correct, and that's good. Write g of x, the dashed line, in terms of f of x, the solid dotted line. Okay, at 3 units, it becomes 3. Well, I know for certain that that will reflect it across the x-axis. That that will translate it left by 2 units. But I want this effect, whatever this effect is. It appears to be like stretched vertically by some amount. Okay, so when I go 4 units along, I get 2. But for here, I go 4 units along and I get that. Can't quite tell what's going on here. Okay, just imagine that they did this thing first. Okay, so like 3, 3. So there. And then something like from there to there. Okay, 8, 5. There. Okay, so whatever that is. Okay, so that's obviously square root. But Like, come on, try. 4, 2 turns into 8, 5. So what actually is that? How? What? That's 3. I mean, this is wrong. Should be here. What is it that I'm not getting? There's something I'm not getting, and I need it to be explained to me. Okay. It's something, but what is it? Okay. I need to visualize. Okay. That's good. Now, plot those 2 points that you know. 1, 1. Oh, 4, 2. Okay. Okay. And now, if you please, go right inside there and do 3x. And we observe that it's there, but why is it there? Why is it there? Why is it there? Come on. Oh man, that's so obvious. Compressed horizontally by the, of course, so that's not actually going through 8, 5. That's all right. Okay. Live and you learn. Let's try now with this one. Okay, so I believe that that's f of x cubed. F of x equals x cubed. Then I believe that it's stretched horizontally by a factor of 2. I would say so. Yeah. And to stretch something horizontally by a factor of 2, you go in where the x is and you half it. Because things happen half as late if you view x as being time. And then it's translated down by 1 unit. And so if you want that in the function verbiage, it would be like this. Half of x and then take 1 from it. And that's correct, and that's good. Next. Okay, so I believe this is the standard hyperbola. F of x equals 1 over x. Then I believe that it's just translated. And then what is it translated by? 1 to the left and 2 up. So we go in where the x is. Two up. There, like that. This is the absolute value of x. And to get that effect, we reflect it across the x-axis. Then we translate it left by 3 units and up by 3 units. And that's... Uh-oh. I didn't even spot that. Oops. And that's good. Identify the parent function, f of x, and write an equation for the function given. The parent function is the absolute value. And the child function, or just the function itself, I guess, is that same one, but stretched horizontally by a factor of 3. So first things first, you go in where the argument is and you put a third there like that. That's how you stretch it by 3. And then you need to translate it to the right by 2 units. So go in again where x is, go in where x is, put some brackets around it, and instead of adding 2 as you might think, you actually have to take away 2. It's almost like the opposite thing happens in where x actually is. And the parent function in this case is the cubic. And the modification is as follows. It's negative in where x is. And it's translated down by 3 units. Okay, and so we check. And it's good. But I could have brought that minus sign out. But that's all good. Okay, yay. Next up, piecewise functions. Piecewise functions. And there are 10 questions to do. Sketch the graph of each function. So I will sketch the first piece, which is minus 2x minus 1. So we have to feed in 2 to get where the function first is. There. And then we need to do this. There, like that. When we feed into here, we get 2 as a result, which means that I need to do that. And then it's the negative of x, but so I get you. So it's like that. There. Okay. And here, when x is less than or equal to negative 2, it always returns 4. So it always returns, beg your pardon, negative 4. And so I go here, and then I make that do that. And then for this middle piece, I feed in negative 2, and I get negative 4. And all right. So it should look like that for now. Then I feed in 2, and I get like 0. Then it goes down by that, and then down by that, and then down by that. And there. And we check, and it's good. When it's greater than 0, it's just 4 take away. Well, I'm going to do it in red so it stands out more. There. And we go down like this. And then and then a little bit more there. Now, it's the negative of the absolute value. So like there to there. Just like that. And then the negative of 2 to the x. So 2 to the -4 is that. It'd be like a nice hollow dot there, and then really, really close there, like that. -6 when x is less than -2. And the fourth power of x, but shifted to the left by 1 when x is greater than or equal to -2. So how does that work? Just stick in -2 first. And we get this. And then stick in -1. No, that's not quite right. And then stick in 0. And then stick in 1. And you'll get 16, which is like way up there. Oh, right. Of course. Not fully awake yet. Should look like any even power. And we check, and that's good. Okay. Next up, when it's greater than 4, return -4. So a nice hollow dot there, and a horizontal branch going to the right. When it's less than or equal to 4, return this value here. When you stick in 4, you get nothing back because this is like an asymptote. Like you get infinity back. So draw a nice dashed line like that. And then just do something like this. And that's good. When it's less than, okay, when it's greater than or equal to -3, return 3 over x. Okay. Oh, why am I not getting this? Okay, so it will be that, but everything's bigger by 3. So like there. And there. And is that right? No, that's not right. Other way. There. And there. And that's good. And now, like, do that sort of thing again. Please just put it in correctly. So 1. So that would be fine. That would be fine. And that would be fine. Like that. And then it's going to be 2 to the x when it's less than that. So there'll be like a hollow dot there like that. And it'll be really close. And that's to be checked, and that's not correct. Keep on mistaking this. Okay. Now, so I'm going to put a little mark there, and a little mark there, and then I'm going to see. Now, when I put in 2, it gives me back 0. And otherwise, it's the absolute value function. There, like that. And over here, it's the absolute value function, but cut in half. Like a curve like that. It's undefined for that region there. Okay, and then this one. There, like that. Like that. It's the absolute value function, but translated to the right by 3 units. Like that. And there, like that. But that should be a filled in dot. Oh no! Whoa, 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 whoa. Not accurate. Okay, try and think it through. What's the square root of 0 under those conditions? Doesn't make any sense anyway, but it's 0. What's the square root of 1 under those conditions? Well, 4 times 1 is 4, and then that gives 2. Oh, I get it. So it will be the square root function, which is growing like really fast. Oh, okay. Write a rule for the sine function s of n, where s of n is -1 when s there. Okay. Oh, beg your pardon. That should be n. Okay. Okay, be well. Be well.